Okay, we're going to get started. So I want to go back, and this is actually some things that were from 1.2 and 1.3 that I didn't go over. I want to go over those right now. So you can put this either on 1.2 and 1.3, or you can make a little section. We're going to start defining postulates and theorems, what they are, and then we're going to talk about a couple. Because when you're trying to prove something, you have to have reasons why it's true. You can't just say that. That's called deductive reasoning. Okay, you start with a premise and you have to make an assumption that's true. When you make that assumption, then you go through and say why it's true. I'm not going to make you do formal proofs where you have to do that, but I do want you to understand what the difference is between them. So when we're working, we have postulates, which to me, when you're reasoning about something that you're doing, you start out with an assumption. So an postulate is an assumption. Okay, it's an assumption. It's something we can't prove, but we all agree it's true. Okay? There are things in life that we can't prove. Okay? Especially as Christians. We believe we are created by God. Okay? We can't really prove that. But as Christians, we assume that's true because there's so much evidence that kind of leads that way, so it's an assumption we believe. Okay, and so that's what we're looking at on those kind of things. Okay, so that's a postulate. It's something that we agree that's true. Now, this is where things can be kind of skewed based on what you believe is true. And so if you don't agree at this point what's true, then your whole argument can go different directions. Because scientists, a lot of time, not all scientists, but some scientists don't believe that God created the world. So their assumption is it came from evolution. It came from maybe a Big Bang theory. There's now Martian theories. There's, some other being coming and planting us, which then that just puts it backwards. Where did that being come from? So, there's all sorts of things. But when they start from a different assumption. Okay, so that's where things can go different. When you're looking, you need to go back to what is the basic assumption people are using in an argument. Okay, because there's always some assumptions. And you have to agree that that assumption's true, or you are not going to agree on the rest of the argument because it's impossible to agree with the rest of that argument. Okay, so that's what a postulate is. Big word for something that I don't care if you memorize the postulates, but I'm going to give you some of the assumptions that we make in geometry. I don't care if you know that they're postulates, but I just want you to know that word in case you ever read it in the book, you'll understand what it's saying. Okay? The other things are theorems. Theorems are things that we can prove to be true based on assumptions, on our assumptions or our postulates. Okay, and so we can prove them true. Using other postulates, other theorems, we can prove things true. Okay, so these are the two basic things that are really used in geometry to do formal proofs, which I do not think any of us need to do formal proofs, just because you'll never use that in the world, I'll tell you that. And I had to memorize all these postulates and theorems for the basic ones, and then as we got farther, they would allow us to use a notebook with all of them because you cannot remember them. There's just no way you're going to remember all the theorems and postulates. Okay, so the first one I want to give you actually comes from lesson 2. So from lesson 2, we were talking about measures, and I got to find the measures. Here it is. They don't give too many. They have what's called, where'd it go? Well, maybe they don't put it in here. Let's see. Lesson 3. Oh, well, maybe it is from today. Maybe I'm... Okay, this is terrible. I know I saw these. Where were they? This is terrible when I can't find something. There's one. Let's see. Where did I see them? Oh my gosh. Okay, so there you go. I can't find them. Well, I'll just tell you what they're. Maybe they're in the next section. And I went to chapter 2 by mistake. Let me see if that's where it's at. Direct proof. Let's see. Definitions. Oh my gosh, I really. Oh, okay. Postulate 1, which we've already talked about basically. Postulate 1 is 2 points make a line. That's an assumption that we have, okay? These are assumptions that we use. We've already talked about that if you have 2 points, you make a line. So that's an assumption. We can't really prove that, okay? We've assumed that to be true, but we can't really prove it. Okay, there's no way to go back and prove it. I mean, you can look at it and say, yeah, that looks like a line, okay? But you can't really say, well, this is a line, because you can't prove what it is, okay? So that's a postulate, okay? The other thing is, whoops, 3 points that are not collinear make a plane. So what that's really saying is if I put 3 dots here, that makes a plane, because now I can look at those 3 dots. It gives it 2 dimensions. A plane has 2 dimensions, length and width. So when you have 3 points, you have a plane. Okay, that's what we assume. So if you're given 3 points that aren't collinear, we can assume that they are on a plane. Okay, they are on the same plane. Okay, so that's a couple of the ones that we've done. Don't want that one yet. We'll come back to this. Okay. Boy, I really went up to. Okay, there's other things here I forgot to add, are definitions. So definitions, this fills in with there. Definitions can also be used to prove things. So this could be also definitions. Okay, so definitions can be used to also prove things. And so one we have is betweenness. So we start with betweenness of points. Okay, and basically it's saying, okay, if you have 3 collinear points, then if you look at them, they're in between. So basically, if you're looking at points on a line, if they're collinear like this, betweenness says basically that B is between, because this section is more smaller, because it's not more smaller, but it's the smaller thing, because A is less than B and B is less than C. That means where they're written, I should write this as a capital A. So B has to be in between. Does that kind of make sense? You know how I define it? These A and B. So basically, if I wrote this is less and this is less, so when I'm looking at it, A is more to the left. Because when we do a graph, we put smaller numbers to the left. So A is smaller than B because it's farther to the left, okay? This one is smaller than C because B is farther to the left. So that means they're in between, okay? Another way you could say it is the measure of AB, okay, which is a line segment, or not equals, is less than the measure of AC. Okay, so do you see that? AB is less than AC. Okay, and the measure of BC, this is another way, is less than the measure of AC again. Okay, that means that B must be in between. Because if these measures are less than this, okay, then B has to be in between. Does that kind of make sense too? Because if I measure this length, it's going to be less than this length. Okay, if I measure this length, it's going to be less than this length. So that means B has to be in between. Okay, so that's another one. Now, do we really look at that and say betweenness of points? No, we just say that point's in between. Okay, do I use this formally? No. Okay, it's kind of the same with betweenness of angles. And this one's a little bit easier because if you have angles like this, now we have two angles, okay? So this is A, this is B, this is C, and this is D. So you can look at this and say, okay, yes, angle BAC is smaller than BAD. Angle CAD is smaller than BAD, okay? So they're smaller than the two, and they are all conjoining here. C is in between there. That's basically, you can see that those are in between. So the angle BAC and CAD are in between the angle that is the big one, okay? So it's a ray that's inside two other rays. That's going to be where it's in between. Okay, so it's very much the same thing. This is when you have a ray from the same endpoint. Oops. That goes between points, the points on the side. I can't spell. Between points on outer triangle. Or outer angle, sorry, not triangle, outer angle. Basically, C is in between B and D, so you know that those two little bit ones are splitting it in half or splitting it up. Doesn't mean they're the same size. Can't say that yet. Okay. Again, when we're thinking about proofs, and I would like to use it as thinking about reasoning or justifying arguments, because that you do in life. You don't justify arguments about trig or about angles and measures and all that kind of stuff. People seem to think that this will translate over to you using it for something else. It doesn't. Believe me, most of people go, I don't understand. You know, okay, yes, I agree with you. I don't understand what we have to do. But in any type of argument or proof that you're trying to say, this is why I believe something, you do start with assumptions. Then you use theorems that can be proved, and you use definitions. This is a big one. If you do not define something the same as somebody else, you're going to get different conclusions. So when you are talking about an issue or you're talking about something, make sure you are defining what you're talking about. Okay? I've seen this happen over and over and over. You know, somebody says, please don't do this. Well, you don't really understand what they're defining there. And they have a different assumption what that means. You need to clarify. That's a really big thing when you get like maybe in conflict with your parents. talk to them about what is the definition of this word, because this is how I view it. How are you viewing it? Because that can resolve conflicts. It really can. Okay. And that's a big deal. You need to resolve those conflicts. Okay. So that's something that you can use all the time. Okay. So that's really what I wanted to cover in that part. Now we are going to go into more chapters 1-4 or sections 1-4 and 1-5. Let's just look at it really quick. So 1.4, the big idea in 1.4 is bisection, okay? So bisection, I'm going to ask somebody to tell me what they think bisection means. What does it mean to bisect something? Yes.
Dividing into.
Yes, dividing it exactly in half, okay? Into. Bicycle, two wheels, right? So bi, or a biennial is, I have to think about that. That's, biennial is every 2 years, okay, if you call it biennial. So this means two, obviously section means section, okay, so this we're doing it into 2 sections. And in geometry and stuff like that, it's equal sections. So if we bisect a line segment, it basically cuts it in half. Okay, that's what it means to bisect it. If we bisect an angle, again, we're looking at the smaller angle, the one that's less than 180 degrees. Okay, if we bisect the angle, then it cuts it in half again. So you come up with 2 that are exactly the same. That's really what bisecting is. Okay, so we use that in other terms, but it's not always used as exactly half. But bisection really truly means in half. Okay, we use it kind of flippantly. We bisected this. You don't use necessarily all the time use that as the exact word in half. Okay, so we're looking at bisecting them in half. Now, another word that we have to define here is congruent. Congruent is actually meaning that they basically are the same measure or same identical thing, okay? So usually when we're looking at 2 things, they are considered congruent if they have the same measure. So if I'm looking at angles, if I have 2 angles, like this, I know I don't draw these perfect, but you know, I'm going to call this A and B because they're not touching each other, so they can be labeled with one letter. Okay, so angle A and angle B would be congruent. You would say angle A is congruent. This is the symbol. Okay, it's not exactly equal because it's not the exact same thing, but it's congruent to angle B. Okay, because they're the same size. Okay, that's what it really means. Okay, one way we indicate is if you put a single line or single arch like that in both of them, that indicates that they are the same. Okay, if you have more than one congruent angle, you start adding slash marks. So 2 that have a single mark through it are the same. If they have a double mark, each of them have a double mark, they're the same. So this is just notation of congruence, okay, on our figure. Okay, this is stating it in a statement. This is showing it on a drawing. Okay, 2 different things. Okay, if you're looking at line segments, okay? Then if you have a line segment here, and I have one here, okay? This is AB, this is B, no, not B, CD. What we put to show that they're congruent or the same size, a single arrow like that, matching another single arrow means they're congruent. That's a symbol for congruency, a little arrow. Again, if you have more than one side, you might have 2 or 3 arrows, but you match it up with the other one that has 2 or 3. Okay, so that's a symbol or notation of congruence. And this would be written that AB, line segment, is congruent to CD. And that's how you would write that, because you have to put the symbol. So one of them is, again, in written form, one of them is drawing form, how you note something's congruent. Okay? So when we're bisecting, we make 2 congruent angles because it cuts it in half. So that's why we had to define congruent. When we cut a line segment in half, you get 2 different line segments that are congruent because they're exactly the same measure. Okay? If you bisect an angle in half, you get 2 angles that are exactly the same size, and so they're congruent. So when you bisect something, you get congruent segments. Okay? Okay, so we are going to look at drawing this with a with your compass and straight edge. So get out your compass and your straight edge. This is where we see who's more coordinated. I am terribly not coordinated, but I can do this sometimes. Definition? Okay, I'm not going to be able to write it on here, but I can show you the idea, okay? So let's go through, how do we bisect, and I think, let's see, bisection, yeah, we bisect an angle in 4, or does that actually tell you? Yeah, okay. Yeah. So we're going to learn how to bisect. It's kind of fun. So I like to do it with this right away so you can see how to do this without measuring, okay? So one way of doing it is to try to measure with your protractor, okay? But we're going to try to do it without measuring it, because when you're really trying to cut an angle in half, it's hard with a protractor. This actually gives you the exact measurements. It will actually cut them in half for you. First, it's how to cut a line segment in half. Okay, we're actually finding the midpoint. So let's start with the line segment. This is bisecting. This is 1 point, well, it's 1.4 with a little bit of Terry added in. How's that? Okay, so let's just draw our line segment. So draw a line segment on your paper, like that. Okay? Doesn't matter, just make a nice straight line segment. Try to keep it pretty straight on there. Okay. Use your straight edge if you, it's actually nice to use a straight edge. Oh, yeah. Okay, so to bisect a line segment, what you do, and I don't know if this is going to be big enough to do this. I have to. You open your compass up, because I did that real big. I'm not sure that this is going to reach, so I'm going to make it smaller. I'm going to make it the line size of this, because mine's no bigger than that. Like I said, this is hard on So your line shouldn't be longer than your protractor for this activity unless you have a protractor that's really long. It's hard to do. So made my line segment shorter, okay? So open up your compass, which should have a pencil at the end. Mine does not because I'm trying to, well, actually it has a point, ouch. No, that's a pencil, okay. So if I were to do this, I match up or get it open the same length. So I put that down, put it open, and then you go up with your pencil up here and draw the arc. And go down here and draw the arc. So you're going through and making like a semicircle through the one point. Does that make sense? So what it did was I basically have an arc. My arc is not going to look nice because I'm trying to draw it freehand. Yours should look really nice because you're doing it with the compass. Okay, so try that. That is your, oh my gosh, that is tiny. This might be old. No, that's good. Okay. Yeah, it goes open quite a ways. Okay. So the first way you do it is put the pointy end of your protractor on the first end point. So you put it on A, this is B. So 1, pointed end of compass, sorry, on left endpoint A, draw, this is 2, draw a semicircle around or from through point B. Now we're doing the opposite thing. Now what you're going to do is you're going to put your pointed end here and put the pencil end on A, and you're going to draw the semicircle there also. Okay? So third step is the pointed end of compass on the right end point. B, or draw the semicircle through
You should have enough for them.
point A. So what you should get, if I can kind of, okay, gotta pull this open. That's a very bad drawing, but you should have something like that where they intersect, okay? So if you're, yeah, depending on how big you made your line, it's gonna be big or smaller on your paper, okay? How we doing? You've got yours, let me see yours.
I don't have a compass.
You don't have, you need to get a compass, you're gonna be using those. Make sure you get one, okay?
There it is.
You guys got a compass?
Yeah.
Good, okay, you did a good job. Oh, yeah, if you make it bigger, it takes up more room. Okay, you've got pretty much the idea, yes. It's a little bit bigger, yeah, I know. So the smaller we make, I'll just give you a hint, the smaller we make these.
I just did full length.
Yeah, the smaller we make them, the easier it's to draw on a piece of paper, okay?
So tiny line.
Now, once you've got those 2 points, those two arcs, see how the arcs intersect above and below? If you put your straight edge through those points and connect them where they connect, that should be your midpoint. Yeah. I'm not guaranteeing mine will be. Especially because I can't draw. It's not bad though. I actually didn't do too bad. Freehanding this without a compass.
Yeah.
So it actually, that then, so we draw the line, so 5, you draw
Oh,
a line through the intersections of the semicircles.
okay. So you just draw a circle and then you reverse which point you jump to.
Oh.
Yeah. You switch.
Okay? And so now this point point right here, that point right there is called your midpoint. So if I named it, I would call it C. So the midpoint is C. Okay. What we know from this is that AC is congruent to CB, or we could write it as this way, put an arrow on both of those to show it's congruent. Okay, so what we just did is we cut that line segment into exactly two pieces that are the same size, that are congruent. So what we got was, we found the midpoint and we know that this length and this length are now the same. So I indicated it two ways. I put the arrows to indicate they're the same. And then I put the congruent symbols up here just to show that they're the same. Okay. We do know that C now also is between A and B, because we know that A and C are congruent to each other. So that, and you notice that there's C in both places, that means C is in between. Okay, because those two are congruent, C's in between these. Well, actually not necessarily. We see that they're collinear, that's why they're in between, because they could be a different direction and then it would still be congruent. Okay, so that's how you bisect a line. Angles are actually easier. I love angles. They're so much easier. Okay, so an angle, this is line, or whoops, this is angle. Bisect. First thing you do is draw an angle. Doesn't matter what it looks like. You can draw the lines out a little farther. When you make your angle, put some points on it. Actually, we want them to be the same distance away. And the way you can find that, so when you're doing your compass, so if you measure with your compass, I'm doing this differently. So if I measure out here, that will be my first point. I'm going to use that to make a line there. This will be my second point I'm going to measure from. So I'm not going to use these points. You want to get those exactly the same distance. So you don't move your compass and use the same distance here to mark a point. Use the same distance here, mark a point. Okay, so you have two that are congruent. So what we've done is we just made these little segments congruent. So let's call this A, this B, and this C. Okay. Now, what we're going to do, this is actually quite easy. You go to this point, put your point in, make a little arc inside like this. So you don't even have to make a semicircle. It's just going to be inside between the two rays. You're going to put a little bit of an arch from C. So what you'll get is something like, again, I'm not going to guarantee mine's going to, but you'll have something like an arch like that up there. Okay. So what you're doing is you're putting your pokey edge in C. Oh, my arch is different. Okay. I'll try to draw it. That's not probably going to be right either. But that's kind of the first idea. Okay. Pointy end at point C, the pencil in inside, make a little arc. Okay.
Where do we need to put our pencil? The pencil's at C.
No, the pencil's not at C. The pencil's just, it doesn't matter. As long as you keep it the same. Don't get it the same distance you're going to use for both points. Because now we're going to turn around and use that same distance. We don't want to change our compass setting. We're going to use that same distance, put the point at B, and strike it through this way. Okay. I know this is going to construct somewhat right there. Okay. So now do you see that little intersection? You see the intersection there? We are going to put our straight edge. I'll come around, make sure you're following it. So
Yeah.
Thank you.
The pointer.
I don't know what
Well, I didn't quite hit it, but
Okay, yeah, we're here.
you draw a line now through that intersection right there, and you've got it bisected. So now this angle and this angle are the same. Okay, so let's put down the steps. 1, measure up each, not measure, use compass to find a line segment on AB, oops, or AB, that's the same
Yeah.
as a line segment on ray AC, oops, 2, okay, don't move compass, so your compass has got to be the same thing, so compass end on point B, small arc inside angles. 3, same compass length with end on point C, small arc. 4, line or ray from vertex A through intersection of arc. That's kind of a step by step. Yes. Yes, you can take pictures of this if you want, and there's also a video. Yeah, that's true. Okay. So again, now we look at, this one actually says, we know that AB, that line segment is congruent because of how we made it. They are congruent to AC. That is a true statement because we had to do that. We had to mark up the same distance on each ray. Okay, and so that tells me these two rays are the same. I also know that now these angles are the same, so I can say the measure of angle, well, actually we don't have to say measure. So the angle BAC is congruent to the measure of angle, oops, I didn't put, that's not right. Sorry, I have to put a number in here, D. Okay, BAD, bad is as good as DAC. Okay, so those are congruent. Okay, again, I put symbols. Let's look at the symbols. The symbols for line segments being the same are those. I should draw this a little bit better because I did it from here. Oh wait, no, from here to here. That's right. AB to AC is the same. So those line segments are the same. I marked that. I also marked that the two angles are congruent because I bisected it. So that means BAD and DAC are congruent. Okay, does that make sense? I'm trying to just show you the different markings so you kind of get used to it. Okay, we're going to practice doing some of these constructions. So how did everybody do? Anybody have any questions on doing their angle, bisecting their angle? You okay? You haven't done it because you haven't had a compass, but we'll have to practice. Everybody at this table got it? Okay. If you don't want to write all this right now, you can take a picture, or remember it is online, so if you don't get it all down, you can go back online and see what it says. Okay, how are you guys doing? You okay with bisecting? Let me see your bisection. Oh, good job, good job, good job. I see it there. Okay, let me see yours. Okay, where's yours? Oh, right there, okay, where's yours? Okay,
Should I roll all
that's
this
good.
stuff?
Good, okay. And you have yours, oh, good job, good job. Okay, looks good. Huh, okay, so that's really bisecting. That's bisections, that's how to bisect an angle and a line. It really doesn't go into all that right now, but I thought while I'm showing it, we might as well learn to bisect both. Okay. So the next lesson is 1.5. So this is going to next one, 1.5. Okay. This is going back into some of our definitions that we might use. So we have to know what these words mean when we're talking about them. Sometimes I don't know why we use them, but we do, so that's how it goes, okay? So in 1.5, what are the two angles we are talking about, types of angles? Anybody know? Look at your notes from 1.5.
You just said to read it.
Yeah, you were supposed to read it. What were the angles? Somebody look in 1.5 and see what it says. Just look on page
They were,
105. Page 105. That section, isn't that? Yeah, that's lesson 1.5.
they were,
No, it's not. Sorry, I lied. I'm in the wrong chapter again.
it's page 30.
Yeah, it is. Oh, yeah, this is not. Sorry.
We're talking about these like.
Yes, we did talk about, so they're pulling back. I'm sorry, I was in a different section. So 1.4 is basically how to find the area of a quadrilateral, okay? This is a specific area for any quadrilateral. It probably should read the same. It should give you the same answers, okay? Now, if you look at the formula, this is just kind of giving you, in history, this is what they discovered first. Then they narrowed it down more and more to be specific for each time of quadrilateral. But if you want to remember just one, what do I want to call it? One formula for quadrilaterals, you can. This works on all quadrilaterals, okay? So this is how to find the area of any quadrilateral. This is a general formula that works on squares, rectangles.
I'm sorry, is this from 1.5?
Yes.
Oh, okay. You
Yeah.
still have 1.4.
Oh, do I? Yes, I do. Thank you. This is 1.5. Rectangles, trapezoids. What's our other quadrilaterals? Trapezoids, parallelograms. And or other quadrilaterals. So they don't have to even be a square, a rectangle, a trapezoid, or a parallelogram. This will work on any quadrilateral. Right? The formula is area of the quad, I'll put Q in there, is equal to 1/4 A plus B and C plus D. Oh, whoops, they wrote it a different way. Okay. And D plus B plus D. So when you look at a trapezoid, or a fourth quadrilateral, I'm just doing a weird one like this. Okay, we're going to call this, these are small letters. Small letters. represent side links. Okay, like capital letters are how we define stuff. So in this, and this is kind of an interesting way, if I have point, well, let's just call it this way. We're going to call it A, and this is B, this is C, and this is D. So you just number or letter the quadrilateral with the 4 sides. Okay? It represents the 4 sides. So we can find the area by finding what these links are, and we can use this formula and get the same thing. So let's just try one. Let's try. Let's do a square. Okay, we know what the numbers are. Okay, we know that I'm going to say this side is 4, this side is 4, this side is 4, this side is 4. True in a square, right? Everybody agree with that? Okay, so if I were to add the 2 sides, the opposite sides, really you're adding the 2 opposite sides together, multiplying it by the addition of the other 2 sides together, and then dividing it by 4. That's what our formula says. 1/4, multiplying by 1/4 is the same as dividing by 4. Okay. So if I take this, well, first of all, what is the area of this? Because we know how to find the area of a square. What is the area?
2.
What?
16.
It's 16, because you take 4 times 4, which is 16. Okay, so let's see if we do it the other way, if we get 16. So now we're using this other formula. I'm going to do it this way, 4 plus 4, 4 plus 4, divided by 4. That's really what 1/4 times that means, because remember, multiplying by the reciprocal is the same as division. So if I multiply by 1/4, it's the same as dividing by 4. Okay, get used to that interchangeable stuff. 1/4 is the same as dividing by 4. Multiplying by 1/4 is the same as dividing by 4. Okay, so 8 plus 8, no, excuse me, 8 times 8 on top divided by 4. 8 times 8 is 64 divided by 4. 64 divided by 4 equals 16. Yes, this was a lot harder, took a lot more steps, but that formula works for every quadrilateral. So if you get another quadrilateral and you can't remember what's the formula for that, it will always work. Okay, so let's put some numbers in. I probably shouldn't. Let's go with this one. 5. That doesn't make sense. Well, you got to imagine these. Okay, so this is going to be 13. This one's going to be 5. No, that makes no sense. That is 5 and this is 13. No, that doesn't even work. It's 15 and 13. I'm really screwing this up. Okay. Let's do it this way. 13 here. It really makes no sense what I'm doing, but that's okay. And we're going to put 5 and 9 here. So you just have to imagine I drew this correct. I didn't. Okay? Let's see. Okay, so we want to find the area of that. It's not a trapezoid. It's not anything that we know. It's a weird quadrilateral. So to find the area, we add the opposite sides. So we add the top and the bottom together. So we get 5 plus 9. We multiply that by adding the left side and the right side together. Okay, so we did top and bottom together, left side and right side together. 15 and 13 is 28. Oh, not that. Gotta write it down. 15 plus 13. And then we're going to divide that answer by 4.
That doesn't make sense.
Doesn't make sense? Why?
How is that 13?
It's fine.
I said you have to imagine my drawing. My drawing is really not to scale.
It's fine.
So when I say my drawing's not to scale, believe me, okay? That's not to scale. It means it's drawn very wrong. When I say not to scale, that means I didn't draw it right. Okay. So 5 plus 9 is 14. 15 plus 13 is 28. To make my division easier or my multiplication easier, I'm going to divide 28 by 4. Because 28 is divisible by 4. It is 7, right? So I just reduce that down. Now I have 14 times 7. Okay, which 14 times 7, who wants to do that for me? It's 48, 168? 98? Okay, well, close. 168, that's not close, but anyway, okay. So that's 98. So the area of that is 98. So it's just showing you that this is a formula that could be used for all quadrilaterals. It doesn't matter what shape. Now we've taken that formula and broken them down for the different shapes. We have a formula for squares, we have a formula for rectangles, we have a formula for parallelograms, we have a formula for trapezoids. Okay, we have formulas for those that look different than this, but it came from this fact. Okay, from this fact, people discovered this was true. They started measuring things, and that's how they came up with that. Let's put our protractors down. Thank you. Okay, so questions on that? We're going to work on that now. Okay, we're going to work on some of this now. So I'm going to turn this off. Yes.
Does that only work with, that only works with